So I'm going to go through this website here. I've zoomed in already, which is Python interview questions for freshers. That's kind of like at least a title of part of the site. The actual original site goes through and talks about Python and the fact that it was, when it was released and kind of like what it was used for and so forth. We're going to jump straight to the interview question part for freshers, and it contains about, let's have a little scroll down, 18 sections. So I think I'll go through that because that will be sufficient for a nice little video. And I will just go to the beginning part briefly, just to have a quick look. But this language was invented in '91, so it's about 30 years old, and it talks about being one of the most widely used and so forth programming languages. It says that it's object-oriented programming language. Well, most modern languages are object-oriented. It's a general purpose language. It does mention it somewhere there. I guess if I do a search for general purpose, I'm sure I'll find it. There we go. A general purpose programming language. I mean, it's used for many different things, but it does have areas of specialism, and a couple of them are listed here, which is machine learning, artificial intelligence, and to a reasonable degree web development and web scraping as well, because it's a scripting language that fits naturally into that. But anyway, we're going to jump over to the interview questions for freshers, and it just sort of like, let's have a look at it. And I don't know if these are questions as much as statements by the looks of it, but we get this first one, which says that Python. So what is Python? You might be asked this. I don't know. What is Python? What are the benefits of using Python, right? Python is a high-level interpreted general-purpose programming language. That's what it is. What do all these like difficult words mean? So the first word, high-level, it just means that it's easier to use or more human readable. So you've got things that are like bytecode or binary, and they're not very human readable. And then like we've got abstractions. So we've got languages like C. That isn't object oriented, and it's slightly harder to read, but if you're a professional coder you can read that relatively well. And then you've got languages that are a bit more simplistic, so they're easier to use, and they're known as high level languages. So that's the purpose of at least the section there where it says high level. So we covered the word high level, and yeah, that's generally what it is. It's just easier to do. Interpreted is a computing term, but basically the language is, as you go through it, it doesn't require any form of compilation. So that's generally speaking what interpreted is. And general purpose, again, means it can be used in a whole number of different environments. So it can be built to, and here we go, be general purpose, that's what it does. It can do a whole bunch of different things. So it supports objects, modules, threads, exception handling, and other stuff like that. So that's generally what it is, and kind of like, I don't know if you're going to call them benefits, because the reality is most languages support objects, most languages have modules, most languages have threads meaning that it can do a number of different operations kind of like at the same time. Again, exception handling. Most major languages will have exception handling as well. But this one's quite a nice one actually at the end, which is this automatic memory management. Now that's very convenient. Again, that's for higher level languages. It's got something that does garbage collection for you, and it's got something called a reference counter. And what that does effectively is, when you go through and you create these variables and you do all of this stuff, it's quite flexible for a novice or a beginner user, because you don't have to worry about deleting the variables afterwards. So they kind of like, the memory sort of like is handled itself, and then you don't get like a stack overflow or a memory overflow or something like that. Everything's cleaned up as it's used. So when you use a variable, once you finish with it, If the reference count will then go to 0, and if it's reference counted at 0, that will be removed from the memory, and that gives you more space in memory. So that's quite nice and quite helpful. And earlier languages never had that, so the coders had to manage their memory. Now that's got pros and cons that come with it. The conveniences that Python gives you means that sometimes it might be slower in certain situations. So just something to bear in mind. Again, it goes through here the benefits of using Python, general purpose, easy to learn syntax. I guess so. We'll go through maybe and see some of that syntax. You've seen it on tons of coding videos and things. I've done enough coding videos. High level data structures, that's quite useful. I guess it refers also, or should refer to, object oriented. And dynamic binding and so forth. So again, we'll see some of this. It says it's a dynamically typed language, and I've kind of like not seen this before in a way, or I have seen it, but my view of dynamically typed was something different. At least it goes. Here's a question that you might get: what is a dynamically typed language? And a dynamically typed language is something where you can basically change what the variable is pointing to. So in like probably the classic, or the language that Python inherently came from, which was C, and you could look at C or C++, but basically you have to statically declare a variable. So you might say, like, I don't know, that if you wanted to have a variable for a string that had a string of characters, you'd have to select a string and then give your variable name S, and then it would be a string, and then you could never change its type. Whereas dynamic languages, so languages like Python, it offers this. You can change the type, and it's perfectly fine. So you can have a variable, it could be declared as a string, and then later on in the code you can declare it as an integer. So you can reuse the variables. It's very flexible like that, and it also has things like inference as well, which means that you don't even have to declare what the type is. They're automatically inferred. So if you say like I equals 10, then that variable I is automatically an integer. Now it says it's a strongly typed language, and I wasn't aware that it's actually a strongly typed language, but I guess it is, in the sense that if this is the definition of a strongly typed language, that 1 plus 2 will result in an error. So if I actually pull up my code somewhere, and I do have it, let's pull it up. I guess it is referring to something like this. So we could do z equals 1 plus 1, and then we could do print z, and we could run our piece of code, and that would be perfectly fine. And in other languages like Node, I think if this was a string like that, it would just deal with it. So it would just say 1 plus 1, and it would give you 11. And if I made that, I don't know, 100 like this, it would just give you 1100. That's what it would do. But for Python, it won't let you do this. But this is actually more to do with classes than anything else, because this is of class string and this is of class integer, and the two classes aren't compatible. So what actually happens when we run the code is we get this error message that pops up. That's what it's referring to as strongly typed. Can only concatenate string to a string. So you can add an integer to an integer, and you can add or concatenate a string to a string, but you can't do both. So that's the reference to being strongly typed in that way. It's not of that much importance. It's kind of like something that you'll use sort of like within the language, and you'll get used to the nuances of various different languages. And Python works in this specific way. Again, sometimes it's an advantage, sometimes it's a disadvantage. It's more a case of knowing what it is. So dynamically typed really actually is referring to something like this, which is, we can say that let's say x equals 10, y equals 20, and then we can do z equals x plus y, and we can run our little piece of code there, and we get the answer 30 down below. But we could, and Python lets us do this on a later line of code, we could say y equals hello. Now, this wouldn't be allowed in other languages, so this is a dynamic part of it. It gives you this freedom and optionality. But what's actually going to happen is this variable y, if I draw a little circle over here, this variable y is now going to be overwritten by this variable hello. That's on line number 6. I've just got line numbers here so we can see it. So it's going to throw exactly the same error. So sometimes that's a convenience, and that's very helpful for us, this dynamic typing, and other times if we forget about it, we get an error message in our code, and you see this time unsupported operand for int and string, because the string came second. So it's looking for, if you've got an integer, it's either looking for an integer or float or something else that can add to an integer, and it can't add a string to an integer. Whereas in some other languages, not all, a few other languages, it would allow it, and it would say something like 10 hello. It would throw that out as an. So it's just an understanding of it is. So that's what the dynamic refers to. So it's an interpreted language. What does interpreted mean? Interpreted means it's read line by line. So you can have compiled and you can have interpreted languages. Here's a list of some of them. Python, JavaScript, R, PHP and Ruby are prime examples of interpreted languages. Programs written in the interpreted language run directly from the source code with no intermediary compilation step, which means that there's nothing in here. We never have to compile this. Literally what happens is the code is read on each line. So, we start with line number 1. Well, that's just a comment. It goes to line number 2, line number 3, so forth. Line number 4, it literally reads it sequentially going down in that order. So that's basically what that refers to, if that question ever arose. But again, you will probably know that already if you're using it, and it's quite logical anyway that code would run in that way. But the reality is compiled code actually also runs in that way, because a compilation has to happen in that way, and you'll still hit your error messages sequentially. So I'm going to say it's not a big deal, but you might get asked a question. What is PEP 8? This is a big bugbear for a lot of people. Okay, it stands for Python Enhanced Proposal. Basically, it's a set of rules of things that good coding practices that you should adhere to. And one thing that I could highlight on that is over here. I've got this little line, and one of the things, or the Zen of Python, is that you don't go over 80 characters. And you might say, well, in modern 50-inch modern world, when you've got a 50-inch widescreen, you don't need to, or it doesn't make sense to have a line over here and not go over it. But actually, it has arisen in a lot of cases, and even in this video, if I was to zoom in a bit more, Control plus, there we go, I've zoomed in a bit more. You can see sort of you don't want your code to go over too many lines. There's things like that, and just basically the conventions and things that happen in Python. So that's what PEP 8 refers to, a whole bunch of conventions that that users should adhere to, that are deemed to be good practice. I mean, one thing here, for example, class, I don't know if it's part of PEP 8 or not, but by definition, a class normally starts with a capital letter, but Python's very forgiving. It lets you could start it with whatever you wanted to. So we could start a class with lowercase, but then someone else reading your code might not, or you would be off convention. So there's various things that are useful, and the same thing, things like docstrings, how they're written and so forth. So they're all, but I think all of those things form what this PEP 8 is, this Python enhancement proposal. The official design document providing information to the Python describing a new feature for, okay, fine. The style guidelines for Python, so it's document style guidelines. So just something that the community can adhere to, but you don't have to. What is scope? Okay, this is the first real actual programming question. I don't know, was this one interpreted? It's not, I don't. It's a general question. This is probably a programming question. What is dynamically typed? So what is scope in Python? So that's a bit more relevant. And you've got a few different types of scope, and it refers to it here. So you've got the local scope, the global scope, module level scope, and so forth. But just generally speaking, scope, and what is scope in any language? I can show it in Python quite easily, but I mean, the reality is I've already got a scope here, which is class, and what it is for the purpose of segregating code into different sections. So here, we're just in the main body of our code, and this is the global scope, right? And then if I was to create a function, so define a function, I'm now in the local scope of the function. So a variable here, if I say x equals 200, 2000, there we go, and I do like print x, what is the value of x? Is x 10 or is x 2000? So that's basically the question about scoping. And over here, x has a value of 10. This is outside of the function. And inside of the function, because we've declared a value of x, x is going to have the value of 2000. In fact, let me just run that little piece of code so I can, this is actually just called function, so I'll just run it. Function just like that. And we've got a print of x somewhere, and we should see 2000 pop up. Oops, I still got that error message. Let's remove the error, comment it out because we can't do that. And that error message will come up useful later, I think, because I did see something later on. But let's hit F5 to run our piece of code. And now we see the 2000. We didn't see the 10. And the reason why it's in the local scope, but there are things that you can do, but these are the nuances. But you can use a global keyword. It's generally not. It's generally, I'm going to say, like frowned upon or not used that much, or considered to be poor practice. So if you're using the global keyword, you need to be thinking about the structure of your code. And the reason why is because you want to be able to parse things sequentially. So it's just a facility that you can use. But anyway, outside of that, so we've got two values of x, and this value of x here and this value of x over here. And if we wanted to share them, there are ways of doing it, which is we could return x over here and bring it back into our code and call it that way. So that's kind of like a very, very crude and light version of what scope is. And actually, like if I go down here, so you've got scope in functions, you've got scope in classes as well. So things inside the class are inside the class. And you'll hear other terms as well as things like scope. You'll also get encapsulation. So it's keeping sections of code effectively to themselves. So that's really what it is. And there's also different levels of scopes. You can have functions inside of functions and so forth as well. And there's also like the outermost scope, I guess, which is where you can import modules as well. So, and they'll go into like this global scope. So I could do an import of NumPy, which is a very popular module, and I'll alias it as well as MP. So something like that, and then we've got MP dot, and we can get all of its methods and attributes, and they all belong inside of the scope, and they're very well defined and very clear in Python. So that's generally speaking what this scoping and modules and so forth at a top level are, if that's ever asked. Now the next thing is, it's interesting how it gets asked in this order really. What are lists and tuples here, and what is the key difference between the two? And really, a list, at least in my mind, a list is something that you can keep on changing. A tuple is something that is going to be fixed. So let's have a look here, or think about what is I guess here what is the real difference. The key difference between the two is that while lists are mutable, tuples, on the other hand, are immutable, which means you cannot change them. This means that lists can be modified, appended, or sliced, but tuples can't. So tuples have less features. So maybe if I copy one of these out of here, or maybe I'll make my own one, which is if I clear all of this, and then I won't clear it all, but if I go further down and I say that x and y, or let's say points, my data points, my point is equal to, and then we have like 100 comma 200 like that, and I've put it inside brackets, the parentheses here. It says tuple, and I'll actually call this point underscore 1, and then point 2, and then equal to 100 and 200. Very, very simply, kind of like the difference is that this one, 0.1 can't be changed and 0.2 can. And one case an example is I could do like 0.2 dot append, and I could add in 300. And if I was to run, so if I was to do print 0.2, then when we run this piece of code, we'll just see that we get 100, 200, 300. But if we do, and this is 0.1, and we do the dot thing, we can see here that we don't even have the append method in the drop down list. We can't append this. And if I try to append it, so already kind of like I'm getting, it's not highlighting it in white, so it doesn't look like it's correct. And actually, like, I guess if I defined it even as a tuple, I wonder if this would, no, it hasn't like commented it, but it will throw the error message basically anyway. We're going to get this as an error. So imagine that we just assumed that we could append a tuple, and we also tried to do 300 and then print 0.1, something like this, and then try to run our code. It crashes over here because the tuple has no attribute append, and that is exactly because a tuple, as correctly as mentioned on the site in a way, and this is kind of like what we'd be looking for, is lists are mutable, which means they can be changed, and tuples are immutable. They're designed to be immutable on purpose. So that's kind of like that. I could have run this on the IDLE, but it's much nicer to run it in VS Code because then we can sort of go and have a look at the code in more general cases. And what I'm going to do again is, because I might run other things, is over here I'd have to comment this out because it's not going to work. So we go over to the next thing. What are the common built-in data types in Python? You know, this is very, very similar to all languages. There'll be a couple of edge case nuances, but every language has an integer. Every language, well, not every language is like most like coding languages have the concept of integers and floating point numbers. They might be called other things like doubles or something, but they might all be wrapped into one, so you might just have the consideration of a number, which is either an integer or a floating point number. I think Node has that, Node.js. Then there's other formats are actually there as well, which is a complex number, so you can have a complex number. It is much less, it's much rarer to come across that just because the mathematics of complex numbers occurs a lot less than, you know, the mathematics of regular numbers, but there's something that's available there. You've also got a Boolean, so these are kind of like three distinct types there. I was going to say like there should be other ones, and there are as well. I'm surprised. I thought string actually would have fallen into okay, it's broken it up into sections here where it's got numeric types and then it's got sequence type, which is fair enough, a nice way of splitting it, I guess. I'm not split it in that way before, but it can be. But then there's also another type here, which is this none type, which is quite common or it is in Python, which is basically if it doesn't have a type, then it's of type none. And again, other languages you know, refer to it in different ways, so you get null or nothing, and so forth. So that's kind of like the types. One of the nice things about types in Python is that I guess there's other types as well, but we'll ignore them for a second for now, is that they're automatically inferred. So here I never had to say, although you did see that I could type hint it that it's a tuple, Right, it's of type tuple, and this one here is of type list. And this is how it's done in Python. Now, you know, if you're in another language, you'll sort of like have to say something like, you know, and if I go further up here, you know, this is an integer. You know, another language you might have had to say int. Oops. Don't know where I was typing down the bottom when I scrolled up the top. But over here in another language, you might have had to say int or integer or something like that. You know, put your semicolons at the end and all of that. Python, it's very flexible. You don't have to do anything, and it's automatically, we can actually do this. We can do print type. And we can actually see what the type is of X. And if we hit F5, just to run our code, we see that we get class integer here. And if I did have a string, but I don't anymore, if I did have a string, so if it was over here and I did print the type of Y, then, and I could print type Y, and I'll print type Y over here, but it's commented out at the moment, so Y is still an integer. But if I was to change that later on in the code, so if I do Y, print type Y, hit F5 to run it, we're also going to get another integer. So we get an integer and an integer again. But if I was to free this up, I would then have to comment this one out. We'd get, in fact, I will do. I'll just put that one there and I'll comment this out for a second. We're going to get Z's going to, I commented, but nevertheless, I got the error because I still left Z in there. I'll put that back. But we see that we got an integer, and that was for X, and then our type for Y was a string. So that's kind of like, it's quite nice. Python does that sort of like very nicely out of the box for users. It makes it fast, it makes it easy, and it makes it convenient as well. So, but on the other hand, maybe it slows things down. And if you've got big code bases, some would argue that you don't know what your code is, and we want statically typed things because it could lead to errors somewhere. So, where it's positive in one way, it's potentially negative in another way. So anyway, I'm going to move this back to being to comment out that hello. Otherwise, if I do run any other bits of code, they'll fail. So we've got all of that's in there, and then there's other types as well, and these are called sequence types, and these are very, very useful, and again, very, very flexible and friendly, user friendly, and string falls into that, which is a series of characters. So we've kind of like already covered it in a way. The string was over here, which is this one here, which is a series of characters. So it could have been a single character, H, or it could be a whole string of characters, or it could be a sentence. Right, all of these classify as kind of like a type, and we get this type inference on Python. So I never had to say that X was an int for it to be known as an integer. So if I hover over the Y here, it says Y is a literal here. If I hover over X now, it says X is lit, but it already knew that X was a literal. So I could type int. But I don't have to type hints. There's an automatic inference for that. But anyway, we move on, and we've got sequence types now. And we've kind of seen a couple of sequences already, because over here I made a list and I made a tuple. But there's one more sequence that I should add that's very, very exceedingly useful. This is probably the most used one, which is the standard list. Extremely flexible, extremely useful. But the next one is a dictionary. So you can have a dictionary in Python, and basically it's a whole set of key value pairs. So key 1 and sort of like 100, and key 2 kind of 1000. And the advantage of this is that D, I wonder if we can do it, D of key 1 or key 2, like if we do this kind of thing, so we could sort of like print the key 1 like this. If we do that, we're going to get 100. That comes out of the code somewhere at the bottom. There's our 100 down at the bottom, and it's linking these key value pairs. And one of the nice things that we can do in Python with these sequences is we can iterate over them naturally. Python makes it very easy to do that. So, and in fact, it does mention it down the bottom. You've got a whole bunch of key value pairs, and we can sort of like iterate over that quite nice. It's also got other things as well, like a set, a frozen set. They're variants in a way of a dictionary, kind of like, that was very crude of me to say that, but they are kind of like variants of the dictionary, where it's, in this one, it's distinct objects, so distinct hashable objects, but in particular distinct or unique objects. So you can't have two objects of the same type. So if you did have a set, so you can have E equals a set in Python, and you could have hello, hello again. I wonder if I'm actually doing this right on here, and then hello again, or world. I'm not sure if I can put 3 things. I might have to put them in as a list inside the set and then print E, because I don't use sets that much, to be fair. I use lists a lot more. Let's have a look. Yeah, it does throw the error. Okay, it's got 1 argument, expected 3. So let's just put this into the square brackets like that and run it again. And what we see is we get hello world. So it's basically thrown out one of the duplicates here. That's very useful mathematically. It's very useful for a whole bunch of things. One of the things that we can do in all of our stuff is we can loop over things very easily. So just very briefly, I guess we can do things like, and Python's very convenient, got a lot of convenience bits, but we can iterate through a list. So for I in, for example, E, which is now our set, we can, let's just do that properly, Control Z for I in E. Over here, we can then print I. So it lets us do these things very conveniently. This is our set is also known as an iterable. So these collections, or our collection, is known as an iterable. So D, we could have iterated through the keys and values of a dictionary. We could have iterated, and we quite often do, through the list item. And I think actually, I wonder if it was in there, but there's even this range item, which you actually saw pop up in the IntelliSense when I did it. And I might run it again, but we can do something like this, which is for I, and we see that we've printed hello and world very quickly, very conveniently, and actually for, you know, this one popped up straight away. For I in range 100, or like, I don't know, 10, we could, you know, print I. We could do a whole bunch of other things, but we can see how quick and convenient it is. So that's what sets are as well. So they're kind of like our types. So we've covered like this whole section relatively well, section 7, which is what are the common built-in data types in Python. So there's a whole bunch of these common ones. These numeric types is what they call them, and then these sequence types, which actually contain to some extent these numeric types, and the string as well, which and these sequences can also contain other sequences, so you can create arrays like 1D array, 2D arrays, and 3D arrays, and so forth. And you can do other things like dictionaries, which are similar to hash tables. So, and then there's more as well. This is actually quite important too. So there's also callable types. So like user-defined types and like our classes. So somewhere in the code, I think I did make a class and didn't delete it. This here is so like type in itself, and we could instantiate the class. That's the word for it. So C equals my class, and now C is of type. And if we actually did print type C, and I'm going to put a little comment there somewhere, just because otherwise we won't see it in our code. But type of C, there we go. So it stands out a little bit, and hit F5 on it. Oops, C equals my class. It needed 1. Okay, let's put in a number for the sake of it. Stop there, because my default class type actually took in 1 argument into this thing. I'm not going to go into the details of it, but it took in 1 argument. So, and it was expecting that. So let's just run that again. But importantly, hopefully now this time it works. We can see here that we don't just have to have the built-in types, you know, like an integer, or could have had a string, whatever. But we can actually have the type of C is class, and it's my class. So we can create our own types, and that's also where like complex numbers comes from, because you could have C1 equals complex like that, and it's of type complex, and so forth. So, and we can construct our own classes, as we can see. So Python offers all of that, and that kind of like answers the question. So that's quite a big answer to a question: what are the common built-in data types? You could be talking about this for a good 10-15 minutes. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things, 11, 12, 13, and that's before we've hit the module parts of it as well. So it's a good half hour's chat just on that alone. Okay, what is parse in Python? And actually, again, like, it's a question that we talk. But when I actually pulled this up and I did this for loop, you might have seen that pop up, which is for, there we go, in range, and you see that there was a little parse statement in here. And what that actually does is, it's just a placeholder to say do nothing, because we can't have this like nothing there. You see the little squiggly thing, it's expecting something in the block of code. And in other languages, you would have had something like this. So that could have been maybe empty there, but the block of code would have gone here, block of code, right? But in Python, the block of code is done by indentation. So, we move this out of here, and we're now in our for loop here in the block of code. And unless something's typed in here, it's going to throw an error. So if I actually run this now, we'll get to the end, and it will say here, indentation error, expected an indented block after the 4 in line number 70. So it's expecting something to be here. And if we didn't want anything in it, it's just a placeholder, we could use a parse statement, or I believe we could use the ellipses, which is the equivalent of a parse statement. So either parse or ellipses, they're both equivalent. That's what the parse statement lets you do. It's like a placeholder if you did get the question. And we see it did nothing after printing for in range 10, but it didn't throw an error message. So that's what the parse statement here is. Generally, and here it says it's generally used for the purpose of filling up empty blocks of code which may execute during runtime. And another place I sometimes put in parse statement is if else, in an if else statement. You can see there's a whole bunch of parses in here. They're placeholders until I fill it out with something. So if x equals 100, then don't do anything, parse, okay. And if y equals hello, then also don't do anything, and then finally do something like print yay. There we go. So these things here are placeholders. If this condition was satisfied, then it wouldn't do anything, and then it'd run through the code, and then we could populate it with our code at a later point in time. So that's generally the parse statement. So I'll kind of leave it here, and I'll move out the indentation just to make it a bit more compact. So see it there, we've got 2 parses in there. So what are modules and packages in Python? Now this is kind of like, I'm going to say that critical or important, and we also see this scoping thing as well. They're defined in a different namespace. Namespace is a word actually that I've seen in C++, and it's referred to in exactly the same way. Now, one of the things that we have is, we might want to create our functions, like a whole bunch of functions, and it could be something like, I don't know, add numbers, right? And it's going to do something, so def add numbers, like this, and it might take in 2 numbers, a comma b, and it might return a plus b. Now obviously we don't need this operation because we've already got an addition, but you might want that, and we might then also want something like subtract numbers, so, and that will be a minus b. Now one of the things that we can do is we can take this collection of functions here, because they're also related to things, and we can actually put them into another Python file somewhere else, and then we can import that Python file. That Python file that we've imported is called a module. Now we can create our own user-defined module. So we've got 2 types of modules. We've got user-defined modules, right, which are things like this, which is functions that we've created, and then we've got we've got built-in modules. So these are modules that come shipped with Python, and then you've also got other modules where you imported or external modules, which you import. So built-in modules, like for example, there's the math module. I'm quite sure there's a math module. Import math. There we go, and we can do math. And if we type in math, we can see everything, all of these functions are available in the math module. So like the cosine of an argument, we could do that, and so forth. And everything's contained within this thing. Now, if we made our own user-defined module, it would be in the same type of way. So, we'd create our module somewhere. It wouldn't be in the body of our code. It'd be contained somewhere nice and neat in another place, so that our code didn't become too long in that bit, and we could refer to the modules where we want. One of the things that we like to do is we like to refer to all of our modules at the top of the code. Again, that's by Python convention. Over here, I'll refer to a module in the middle. It's perfectly fine. You could do that, but the convention is to refer to it at the top, because it kind of like tells the user what things you're actually going to be using in the first place. And here we can see that it's grayed out until I sort of like do let's just do something like p equals math. Oops, what did I just do there? What was I typing? P equals math dot, and then hopefully there's a pi there. There we go, pi. And I'm presuming, no, I think it might just be like that, and then print pi, and then some, you know, p. There we go. So we're actually sort of shortening it down. Everything's contained in the math module, and there we go. Pi, it comes out there. So everything was contained in this module, and you could kind of like see from the module that there was just a whole bunch of things in there. All of these functions, look how many of them there are. I don't know, like 30, 40 functions that are in there. So we get all of these modules that are there. Now, there's some very popular common modules, like external and internal modules. So if you wanted to do web scraping, for example, that would be an external module. Requests. Import NumPy and NP. These are very popular modules. You can alias the modules as well, which makes it quite nice. And then also you could do import pandas as PD. We do this aliasing. That's quite neat. Python offers aliasing. Because then you can call all of these features. So pd dot, and then it gives you all of the things that are in the pandas module. So that's basically a very quick definition of what modules and packages are in Python. So it gives you this simplicity. Work on a single module helps you to focus on a relatively small portion of the problem at hand. It sort of like collects it all into one little place. Maintainability, again, all of your stuff is sort of like in one place, kind of like out of the way in a position of the code that it should be. Reusability, now this is a huge one, because if you're using a function and you're going to use it multiple times, you don't want to repeat yourself on code. So, and I think the phrase is DRY, do not repeat yourself, or something like that. So this reusability, anywhere that you're going to use something multiple times, you'll put it into a function. If you're going to use this collection of functions many times, you'll put it into a module and you'll just keep calling them. So there's some very, very popular modules in Python, and you know, some of them that I've sort of like listed here: NumPy, Pandas, Matplotlib for drawing plots. Depending on the space that you're in, and NLTK for doing natural language you know, processing for AI stuff, a whole bunch of things. So that's kind of like what the modules are. Scoping, well, as we said before, if we've written things in our module, then they are scoped to the module, they belong in the module. So I can't see any of this, anything in the NumPy module, although I've imported it as NP, unless I explicitly do NP. And if I didn't have NP, by the way, and I could just have NumPy here, just like that, I just need to do NumPy, so that the NP is just a short aliasing of it. But in order to expose all of the stuff, so everything's encapsulated in this NumPy module. Now, in order to get the features of it, I have to do np dot. So it keeps it all segregated from my other code. And notice one thing, I made an add function, and here there was like an add function. Now, I might have made an all function. Now, there's an np dot, it looked like there was an np, well, it's an np dot add. And it's definitely an add function, so add, right? There isn't an add function, but I might have made an add function in that case. So I might have made a function down below called add. So def add. And if the NumPy, if I didn't have to call it with this NP like that before it, then I might overwrite this function with a function that I created down below inadvertently. That would be an error, basically. We wouldn't want to do that. So it's kind of like throw an error to overwrite a function. So it's nice to do that. And if you did want to import something very explicitly, we'd say something like from NumPy import add, right? Import add. We do something like that, even if we were going to do that. So, and it's very explicit, and that way it avoids making any sort of like overwriting errors in Python. So that addresses part number 9. Let's go on to part, which is what are modules and packages in Python. That was kind of like a good overview. Hierarchical structure using the dot notation in a namespace. Now this dot notation is, I just find it very user friendly. Other people say like, I want to remember all of the stuff because, you know, I'm a great coder. I don't. You saw me doing this all the time. Sort of like np dot, because it exposes all the methods and attributes. So this dot notation is really convenient in the modern coding environments. So in the modern editors, should I say, not just coding environments, where when you do the dot, it pulls out all of the things that are applicable to that module. So that's really helpful. It's a very, very helpful feature, which is quite nice. And again, it avoids clashes between global variable names in similar packages. So it's like this naming clashing, it just avoids it, and it's quite nice for doing that. Global protected and private attributes in particular, so we see it here, which is this underscore, or this, so protected is this single underscore. I never fully know the full difference. Well, I do kind of, or you can get a double underscore, but basically in that is in our, so if we have a class here, and actually we did see it, we've got this double underscore, and again this is convention in Python, which is if we want something to be private, Python doesn't have a method of something being private, so by convention, private function, there we go, I've got this private function now, or private method. I should call it a method, not function, because it's inside a class, so private method. And then, you know, take in the self keyword because it's going to refer to itself, but something like print hello. Now, when I did C before, I could have done, or at least down below, the dot notation again comes to the forefront of this. So C dot, what we see is I got C dot A, and I can also see C dot private method. Now, I wanted this to be private, I didn't want it to be public. And the convention in Python is to put like a double underscore in front of it, or a single underscore, to say like it's protected or it's private. Please don't, it's to say like, please don't touch this. So Python lets you touch everything. So everything is actually public. So we have to have this convention there, like put this double underscore in front of it. Now we see it's kind of like gone like that. But what would happen is C dot. There's our private method, but because of these two lines, we kind of like see it as like this is a private method. It's not to be used outside, really. It's something that's intended to be used inside. It's intended to be used inside of this class. So really, that's kind of like, I'll just do that again because the drawing was terrible. Here's our class. And our private method, we're just saying it exists, and here is the indentation. It exists within this block of code. We don't, although we can use it outside, so we could call it here. We don't want to. Our main intention is to use it somewhere inside our class, somewhere in this piece of code. So that's basically a very short summary of that. But that's pretty much it. Now, that kind of like leads nicely on in a way to what is the use of self. Again, self is used to represent the instance of the class. That's what it is, but self isn't actually a keyword or anything in itself. And it says with this keyword, but actually it's not a keyword in Python. Python's very flexible. It lets you do anything that you like. So I didn't have to call it self. I could have called it S. And I could have called this one S. And also this one S. Now, what happens is when you define a class in Python, the first variable inside any of the methods refers to the class itself. So, and we won't get too much into detail of it, but by convention, because it and in at least in Node.js, I think the reference to the class itself, it uses the this keyword. In Python, it tends to use the self. By convention, we call it self, just because, I don't know, it's easy to see, but it doesn't have to be. The code would work both ways. So this first variable here refers to the actual class itself. And then the second variable are the variables that might get used. So, and that's how we refer to methods and attributes of the class with in methods or attributes of the class whilst we're inside the scope of the class. We use this self keyword. So that's basically what that is. It binds the attributes with a given argument. Or let's go with this keyword. You can access the attributes and methods of the class in Python. So it literally says it. It binds the attributes with the given arguments. Self is used in different places, often thought to be a keyword, but it's not a keyword. It's just a very kind of like strong convention, should we say. But unlike C++, self is not a keyword in Python. There we go. Okay, so it does say it. Initially, it said it was a keyword, and I was like, oh, I'll take offense to that because it's not a keyword, but actually it's not. There we go, it says it. Python offers us this immense flexibility. Now, what is in it? Because we saw this double underscore in it, and it looked a little bit messy. When we make a class in any language, we need to construct the class. It's called a constructor. This is spelt wrong, by the way, in this piece of code. It's called a constructor. Maybe I can send the owner of this website, I can send them the comment. You got a typo there. You want to construct the class in some way. Now, the init method in Python is the way that is the way of constructing. And what happens? Well, I'll read through anyway. Init is a constructor method in Python. It's automatically called. So this is the important part. Is automatically called to allocate memory when a new object or instance is created. All classes have an init method associated with them. So we may or may not use the init method, but they got an init method associated with them. It helps in distinguishing methods and attributes of the class. So basically what happens is when we create a class, we don't have to have this init here. But basically, if you do have this in it, it's called, and we can do things that initialize the class. So it's effectively a constructor, and it says in our case we've just got a here, but maybe we want it sort of like my height, right, of the person. So now we could. So we could say something like self.height equals height. Again, this is just convention, but and then if we did that, now what goes into here, we see in my class, what we see is that our class is called my class, but it now takes this argument, and notice it didn't take, if I can do the drawing, this self keyword, it didn't take as the argument. What it actually started looking for was these, and if I put more variables, all the variables afterwards. So this variable here made its way into, when I did type in, when I did do hover over it, we see that it made its way into the height part over there. So, and that was what it was, and it's of type integer. I'm not sure why it got inferred to as a type. Well, so maybe it got referred to as a type integer here because I put an integer in. Again, that's Python doing all of its clever stuff for us. It's type inference, which is quite nice to have. When you understand how it works, it's very useful for you because you can make it work to your advantage. So that's what the init method is. So there's a couple of other things here. I'm going to kind of like try and fly through this as quick as I can. We're on number 13. But what is break, continue, and pass in Python? The break. These are all things to do with loops, and we've done a loop in a way. So I'll refer to, I guess, the loop that I've done here. But for I in range 10 here, we might want it to, we could print I, but what we might have done is do an if statement. If I is greater than 5, then I could even indent it, but I might just put it here, break. So now we're no longer going to go beyond 10, we're going to break here. So I might put 2 bits of code in, print, just to see. Let's break out of the loop. So that's what the break statement will do. Hopefully it works. There we go. It says let's break out the loop. We only counted to number 6. So when I is greater than 5, we got to numbers. Yeah, it needed to. So it got to 5. When it got to 6, this statement was then invoked. Let's print break out the loop. And then it broke out the loop, so it won't do further than beyond 6. If we stuck in a greater than or equal to 5, then it would have broken 1 bit earlier, which was break out 5. So that's kind of like what the break statement does. The continue statement, so it terminates the current iteration of the loop. So let's just stick in I wonder if I could do that. If I put a continue before I break, it might not even break in that case, because it will just continue to the next one. So continue. Let's just have a little run of it. We can see that the break now has become grayed out and emitted. Now it goes all the way back to 10. So the continue kind of like says, well, let's do, I wonder if I can put it in a better position. We could do something like, we'll do it. If I is greater than 3, or if I equals 3, right, continue. There we go. And that means it won't do the rest of the stuff, and kind of like, it won't, I was going to put it before the print statement actually, so let's move this one a bit down, and I'll enter. It now won't print number 3, because when we get to 3, it's just going to say, continue, just jump over that particular loop. So if we run that again, we can see 0, 1, 2, and then 3 is now missing. So we can sort of like print 3 is missing. So that's what continue does. So again, it's handy. There's certain reasons where you might use that. I don't use a continue statement that much, which is why I wasn't that fresh in it, but that's what it was. And pass was, we've already mentioned it above, it's kind of like a placeholder. The pass keyword in Python is used to fill up empty blocks. That's what it's generally used for. It's similar to an empty statement represented by a semicolon in a language such as Java, C++, and JavaScript. There we go. So if you didn't want to do anything in C++, you'd put in a semicolon. In Python, you have to put in the pass keyword. And again, we could have, like, somewhere in our thing, written pass, but in our loop. But we covered that. So the next thing are unit tests. What are unit tests in Python? I don't use unit tests that much, but like if you're doing like big bits of code, because I test anyway, I do lots and lots of tests. But unit tests is, I guess, much more formal and specialized than just kind of like testing your code. So unit test is testing a framework in Python. Unit testing means testing different components of the software separately, basically making sure stuff doesn't break, especially in big code bases. Can you think about why unit testing is important? Imagine a scenario where you're building software that users have 3 components, namely A, B, and C. Now, suppose your software breaks at a point in time. How would you find which components was responsible for breaking the software? Maybe it was A that failed, which in turn failed B, and then it actually failed C, and so forth. There's maybe lots of combinations. Unit tests help with all of that kind of stuff. Now, the reason I don't use unit tests is because I just do my own testing, but some people are very, very religious about unit testing, and if you're in a bigger place, they would certainly be using unit testing. So anyway, this is why it's necessary to test each component properly so that we know that the component might be run. Now, I might go through, because I thought I did see something. No, arrays, we got to number 18. Okay, we'll continue anyway. What is a docstring in Python? Right, I use docstrings all the time. Docstrings are really, really useful. It's a multi-line string. Basically, what it's there for is to help with the documentation. Like, you're very likely to be you're definitely likely to come across it. But basically, when I made this function, we saw that there was something like this for a class, and over here we saw that something here for a function. Now, imagine that my code block was like 1,000 lines long or 2,000 lines long, and I sort of like wanted to call my function somewhere, and I sort of like didn't know what it was. Down below, I can kind of like, wherever I did call my function, I'm going to try and find it somewhere, wherever I did call it, if I did call it, there we go. If I hover over it, I get all of this stuff that comes with it, and the docstring enables us to have all of these things that are in there, and it gives us like a description of everything that's there, and that's very, very helpful. It's telling someone else who comes to read your code what the function does. And a typical format of a docstring is something like this. Well, first of all, if you've got any arguments, you'll probably even really good practice is to sort of like say A, and it's like, you know, it's of type integer, you know, and B is of type whatever you want to do with it. But apart from that, you've got like, at least in the beginning, you've got like a string that's like tells you what the function does, but then you might have other bits, which is the arguments. And if I did have arguments in here, I'm going to go a int just like this, right? I might not even put any integer bit here yet. Right, I'll just leave a, right? It takes in one argument a, which means that when I call my function somewhere down below, I now have to stick in something, otherwise it will fail. But these are my arguments. And actually I'll put in a b as well, just for the sake of it. There we go, make a function, a and b. And when I call my function again, I just to make sure that I put in something for b, like 10, again, 10 and 20, there we go. Over here I've got my arguments, and basically I want to say something. I'm going to describe to the user what the arguments are. So I could say a is a type integer for a start, and you know, the first number. B is another integer, and it is the second number. Now this might actually, in a way, I'm going to take this docstring because it's probably more applicable to, so I'm going to jump down here and actually put it on one of the functions that we were describing just down below. We're adding numbers, right? So it suits this purpose here. This is a nice docstring to say add two numbers and get right, add two numbers and get the sum and return the sum. There we go. That's our docstring. And finally, what you know, in our thing here, return in our docstring, not thing, in our docstring, return basically the sum of the numbers. Now, if I go anywhere and sort of like do this add numbers, right, over here, if I go down add numbers, we can now see all of this stuff that comes up. It's got A, which is any, B, which is any, and it returns you something back, which is any. We could do like, but it's actually describing here A. We're telling the user it's an integer, and that's the first number. B is an integer, and it's the second number, and C return the sum of the two numbers. Now, we could also do a bit of type hinting here, which is to say that A is an integer, B is also an integer, and we could even say that was for subtract numbers. We could do that up here as well. Sorry, I'll do that on the right place. Integer, and B is an integer over here. I'm going very fast, but we're going to get the point of it. When I do this add underscore numbers again, we can see that we get, it's all gone in green and nice. A is of type integer, so the user knows what to put in. They know how to use the function. So this docstring, not only have we done this type hinting, I'm going to put type hinting with docstring. Like, there you go. If you ever get asked that question, elaborate. Let's do type hinting and docstring, and also say what, but Python's done a type inference now, because this is an integer and this is an integer. It can see that it's got an a plus b. If you're adding two integers, you're going to get an integer back. Python recognizes that for you and kind of even helps you now. But you've helped the user, you've told them what it is, and you told them what it's going to do. Now, it's not so applicable for a small function like add a and b, but if it was something that was quite big and, you know, you had 30 lines of code and you had some sort of you know, great physics formula in there, you might want to describe what's happening and how to use the function and so forth. And functions can become very complicated as well. So that's basically what a docstring is. The docstring should describe what the function or method does. That's the simple one-liner of what it is. And it's a multi-line string. So what does that mean? A comment is one line. This is a whole block of a comment. It's all one contiguous thing. one contiguous block. It's for the user. It's not for the computer. The computer doesn't do anything with the docstring. Doesn't execute any docstring code. It's for the users to use. So, what is slicing in Python? So this is kind of like a bit more advanced in a way, or not more advanced, but it goes on from what is a list. But basically, Python again offers this very nice feature, and this is like one of the attractions of Python in a way. So you've got so like my list here equals, and then it's like 1, 2, 3, 4, and let's actually make some like 10, 20, 30, 40, something like this. We've got this big list. And we can take parts of our list. So we can do like let's print, right, my list, right? But we don't want to print all of my list. What we want is kind of like the last elements of the list. And we could do all kinds of fancy things with it. So if we didn't want the first element of the list, we wanted everything onwards. The first element of the list is element number 0. So we want everything from element number 1 onwards, right? Maybe we wanted everything from element number 4 onwards, so which is 0, 1, 2, 3. Because remember, indexing, lists. It is indexing. Indexing of list in Python, the counting of it starts from 0 and it goes to n-1. So this is the 0th item, and this is however many items there are in this list. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's item number 8. But anyway, the point being that we might want to start from like item number 3 in the list. And if we do that and hit F5 just to run it at the end of our code, assuming and broken it, there we go, we get the balance of the list. But we can do all kinds of clever things with the slicing, so we can do it the other way around like this. So this is what slicing is. We might only want the first 4 items in the list, for example. So item number 0, item number 1, item number 2, item number 3, and item number 4. We'll get all of those things printed. So if we run it that way, we get, there we go. We've got it the other way around, so we've got 1, 2, 3, 4. But we can go even cleverer. Python lets us do something like this, which is we might want to get all of the items. So start at 0 and go to, let me just check there is that long. 1, 2, 3, 4, 5, 6, 7, 8. We can even use negative indexing actually. Why do I need to count it? And then put the step in. So let's get every other one. So like step 2. So it's going to go from the first element. This -1 is negative indexing, which means we're going to go backwards. So we're going to go this way instead of going this way. So we can get lets us count forwards, it lets us go backwards. So we're going to go from the front of the list to the back of the list, but every step basically. So the syntax for that actually looks like, if I get rid of this arrow thing, something like start, end, and then step. Right, lets us do that, and hopefully if I run that it'll work. And there we go, so we've got 1, 3, 10 and 30. So it's skipped every other one. I'm going to skip put spaces in between them so it's a little bit clearer. You do and don't have to, it's up to you, I guess, whether you do for the purpose of clarity. So that's what slicing is all in one go. There we go, this start, stop and step. I was very close. I had start, end and step. So this bit here is stop, whatever, start, end and step. It's the same thing. That's basically what it does. We can do some very clever stuff. We can also loop through this one backwards. So we can do, just like we could do negative indexing, we can do negative hopping. We can hop backwards this way. So whereas we were hopping forwards, going this way, we're now hopping backwards the other way. So we can do either, or we can do what we choose. So if I just do that, then I'll do the same thing. We're making our step effectively this time negative, -2. Let's go the other way. So F5 to run it, and we're going to go backwards now. So our first item is 30. Remember, we've hopped over 40. Then our next item is 10. Then our next item is 3. Then our next item is 1. We got to the end of the backwards hopping list. So very, very convenient, massively useful for a whole bunch of things, and it's certainly useful for scripting very fast. Now, This one here is explain how you can make Python script executable in Unix. But the fact is that I'm doing something on an Oracle web server, and everything I've done, I haven't, like you notice, I'm doing this in Windows. But everything I've done, I haven't had to put anything at the top of the code. But it wouldn't break anything because it's a comment. I definitely didn't do this at any of my code for an Oracle server which is running on a Unix, but I guess it's going to be good practice to do that. That's at least the answer that's being looked for. So I can skip that one over. I'll call that one done. But that's basically a script file must begin with that. That's basically it. What is the difference between a Python arrays and lists? Right, I've never used this array thing before, and I'm going to say I actually went and had a look at this earlier before I actually did this, and I was like, oh, that's quite nice. You've got an array function, but I never use this. And the reason why is because by far the most popular package, which is an imported package, you do a pip install of it, is the NumPy module. And really, the way that you create arrays in Python is nearly, I don't know, always is through the NumPy array. So and if you're importing this module, and it's because it gives you like a whole bunch of extra functionality that the arrays module doesn't. And so when I did this import arrays, which I can do, import array like that, then I could do array dot, and you can see on the dot notation there are things that you can do, but by no way the same amount as a NumPy array. So it's kind of like, you know, I think I'd prefer the NumPy array. Here you go, MP dot, and then you can see there's all of these things that you can do. But one thing you can do is MP array. Right, this is an array. The important part is what is an array, but that's not even a Python thing anymore. Is what is an array anyway? Python offers you a list, and that looks like an array, but it's actually not. An array is a list is flexible. It lets you put in a whole bunch of different things. So if I had, and I'll actually put the array down below. So X, I'm going to take this and I'm going to stick it right down below where the list was, just because I created this my list. So here we go. I will create another list, which is my array. So not a list, my array, which is an MP array. But inside the array, I can actually even stick my list. I can stick it like that. I can literally put my list in here, like this. But alternatively, I can actually put in the items of the list. So something like this. Now, the key difference between, or one of the major advantages / disadvantages of a list is that a list you can put in anything. So I can put in hello over here, and I can put in, I don't know, true. There we go, a Boolean type over here. And when I run this piece of code, all of the same kind of stuff will happen. There we go, it printed in fact. Now, this occupies more memory. It's slower to traverse through, but it's very convenient. So, on the one hand, a list is, we'll just say, let's make a little table somewhere here, the list, and then we've got the array, right? We'll just call it convenient, right? Right. Convenient. Why? Different data types. There we go. The array is less convenient. Right. These are all similar. So if I have an integer, I always have to have an integer. What happens if I make a list in my array and then I go like hello? I wonder if anything happens there like that. Let's have a look. If it throws its toys out of the pram or not. No, it enabled it, but it would have actually changed the type, I guess. So I've still got to be careful about that. But what it will do is it will change the type of all of these to the biggest type here, which is hello. So let's just stick the 10 back straight in here. So everything here will be forced into being a similar data type in the actual array itself. And well, I could actually print out, like if I did change one of these types and then did print type. So if I selected print type and then of our my array, want, I guess, the 0th element. So if I did something like that, I'll print that at the end, just so that we can see it. It says it's of type. We see we get this special type, this numpy int32. And if I go in and stick in a hello here, and notice I was referring to this first element here, but I can actually stick a hello in here, right, and then hit F5 to run it. I think it's going to change all of the types, right? It's now a numpy string, so all of these were forced to be of the same type. So this is one of the things. Now, it's the advantage and a disadvantage, and I'll go through why. But basically, so everything's of a similar data type, and also here on our list we can append. We can append pop, which we can add items to the list, remove items to the list, and so forth. An array is not flexible or fixed in size. We can change the sizes of arrays, but like that would partly defeat the purpose of it. So now, what's the point? Where's the advantage in? Because so far an array is less convenient. It forces everything to be of the same data type, or maybe you didn't even want that. It's fixed in size. That sounds all terrible. The advantage of it is that this is slow and this is fast. This occupies more memory, and this one occupies less memory. So I'm going to correct the word. And this, so basically, this is inefficient, and this is efficient. Now, quite often you might see or hear comments that Python is a slow language compared to other languages and so forth. But that's not actually true. Basically, it's being used in a way, and we do tend to all do this. I'm as guilty as anyone else. We do tend to use the convenience. We're using it for the purpose of its convenience quite often. And so whilst we're using it for the purpose of its convenience, really when we want to gain speed or do higher processing or stuff, there's a couple of things we can do. One is we can call it another language anyway, but the other thing is we can call one of these modules. And these modules, like Python sits, or the versions of Python we use are known as CPython. It utilizes the C language, which has all of the speed and the advantages in that way. And we want to call those powerful libraries in when we want to do data crunching and fast number processing. So it kind of like Python offers us the best of both worlds in that way. We've got our listings and our scripting and stuff that we can do very quickly. But on the other side, it offers us the power of all of the power that kind of like C offers us when it comes to like vectorized processes, like fast processing in like arrays or NumPy arrays, contiguous blocks of memory, that you can operate on seamlessly all in one go. So that's kind of like the key difference. Let's just have a little quick read through. Arrays in Python can contain elements of same data type. Okay. Arrays in Python can only contain elements of the same data type. They're fixed in that way. A data type array should be homogeneous. It means that it's all of one type. It's a thin wrapper around the C language. That's what I was referring to. Around C language arrays, and consumes far less memory than lists. And it's also faster as well. Should have been added on there. Lists in Python contain elements of different data types, which we saw. We went through in a little muck around with it. Data types of lists can be heterogeneous, which means they can be all of different types. So we've got these two like complicated words here. Throw them in: homogeneous and heterogeneous. Basically, homogeneous means all of the same type. Heterogeneous means it can be of different types. But it's got the disadvantage that it consumes a large amount of memory. So we don't get everything. You're given with one and taken with the other one. If you want the convenience and the niceties of a list, bear in mind that it will slow your code down a bit and it will consume larger memories. So it's great if you're doing small lists, if you're doing small arrays and stuff like that, and small calculations. Lists are perfectly fine. They won't it won't hold you back. But if you've got like some 10,000 element array that you want to compute multiple times per second, you're going to probably want to migrate to a NumPy list, and that's kind of like the core difference. And also in terms of memory size as well, for the same reason, you're going to want to go to you're going to want to go to a NumPy array. I called it a NumPy list. You're going to want to go to a NumPy array. So an array is definitely a thing in Python, and a list is definitely a thing in Python. And that is the key difference between them. And I'm going to leave it here. I'll probably pick up on the next video for Python interview questions for the experienced. So everything that was done before was for the not experienced, and then we'll see some stuff for the experienced people. If you found this useful, hit the like button, hit the follow button, forward on to other people, do a share, all the rest of it. It'd be very nice. If you've got any comments or questions, definitely put them in. If there's something that I got wrong somewhere, also put it in. I am an R a lot, quite a bit, but that's because everything I do is live. I haven't like pre-prepared it or anything, so you've seen someone just go through it as is, kind of like as live as possible, answering it with the knowledge I have to hand. I could have, but I didn't actually this time pull out, a Chat GPT or I now use Claude or a Google Bard, but but basically everything I do is live, so that's basically it, and that's pretty much it. Yeah, again, do hit the like button, and that's it. That's the end of this little video.